This video will be a tutorial on the 1968 College Board AP Chemistry for your response, question 3. We'll start by looking at the problem. We have an equilibrium equation of N2O4 on the reactant side, and on the product side we have 2NO2. The reaction above is carried out in a chloroform solution at 8 degrees Celsius. At equilibrium, 0.1 liter of chloroform solution is found to contain 0.7 mole of N2O4 and 2.8 times 10 to the negative 4 mole of NO2, also at 8 degrees Celsius. In part A, they want us to calculate the value for the equilibrium constant at 8 degrees Celsius. In order to calculate this, we will need to set up a Kc equation. Kc will be equal to the molar concentration of NO2, and we'll square that due to the coefficient in the equation, over the molar concentration of N2O4. Meaning the products over reactants. In order to find the molar concentrations, we will need to take the number of moles given to us in the problem, which for N2O4 will be 0.7 over 0.1 liter, and you will get 7 molar for that. And then we have 2.8 times 10 to the negative 4 over 0.1. And we will get 0.0028 molar for that. Now we will plug these numbers into the equation. 0.0028 squared over 7, getting a product of 1.12 times 10 to the negative 6. This will be our answer for part A of the problem. Now we will move on to part B. Part B reads, using this constant, calculate the moles of N2O4 and NO2, which would be present at equilibrium at 8 degrees Celsius when 0.1 moles of N2O4 is dissolved in enough chloroform to give 0.2 liter of solution. Okay, since we're going to be needing the answer that we calculated in part A, we are just going to write this to the side just so we remember. Now, we are going to set up an ice chart for this problem, or this part of the problem. N2O4 and 2NO2. And over on the side, we have our initial, we have our change, and finally we have our equilibrium. For our initial, we have 0 for the product side because it is a product and at the initial stage there's nothing there. For the reactant, however, we will use the 0.1 that they give us in the equation or in the problem and divide it by 0.2 liters, which they also give us in the problem, and we will get 0.5. Making our initial 0.5 moles. Now, as far as the change goes, we will have 0.5 minus x, not knowing what x is because that is what we need to find. And on the other side, we will contradict the subtraction of x and add x. However, we will need to put a 2 in front of this because there is a 2 in the equation, leaving us with our equilibrium at 0.5 minus x and 2x. Now, in order to find the x, we will set up another Kc equation. Except this time, we have the actual Kc number, and we will just be solving for x. So we will put our Kc equal to the concentration of 2x squared again over our concentration of 0.5 minus x. In order to find x, we will need to first cancel out this fraction so that we're not dealing with it anymore. We will distribute this number into this and get 5.6 times 10 to the negative 7 minus 1.12 times 10 to the negative 6x equal to 4x cubed. Squared, I mean. Because we distributed this exponent into the 2x. After doing that, we want to get all of these numbers on one side so we can set it equal to 0. So we'll have 4x squared, and we'll add this, plus 1.12 times 10 to the negative 6, and we'll subtract this, minus 5.6 times 10 to the negative 7 equals 0. Now, after getting this, we realize that we need to do the quadratic equation in order to solve for x. So that would be minus b plus or minus the square root of b squared minus 4ac all over 2a. And that is what x equals. Now, in order to solve for this, we will plug the 4 in for a, the 1.12 times 10 to the negative 6 in for b, and the negative 5.6 times 10 to the negative 7 in for c, all giving us an answer of x equals 3.74 times 10 to the negative 4. Since we have to add and subtract this, we will also get another answer for x. However, that comes out to be negative, and since equilibrium cannot be negative, that answer does not actually exist. Now, since we found our x, we will now plug this into our equilibrium expressions. So our N2O4 will be 0.5 minus 3.74 times 10 to the negative 4, fourth, and that will equal 0.4999, which is almost 0.5 moles. Now, for our NO2, we have 2 times 3.74 times 10 to the negative 4, which is equal to 1.39 E times 10 to the negative 5 moles. These are our answers for part B of this question. And now we are done.